All right, everyone, we're in chapter 5 now, and section 5.1 is factoring out common factors. So let's talk about what a factor is first. So factors are numbers that you can multiply together to get another number, right? Or even expressions that you can multiply together to get another expression or a polynomial. Okay, so when we talk about factoring out common factors in this lesson, um, first of all, to factor an expression means to write an expression as a product, right? So here 12 we can factor it and write it as 4 multiplied by 3, right? So once again we write it as a product. And so and these numbers 4 and 3 are the factors of 12, or at least two factors of 12, right? 12 has more factors like 1 and 12 or 2 and 6, right? But anyway, so that's one way to write out 12 in its factored form. Okay. And another word for factors that we've talked about before, divisors, right? So 4 and 3 are divisors of 12. All right. Now, so this is one factorization of 12, but there's other types of factorization, right? We talked about 12 we can also write as 2 times 6, or we can write 12 as 12 times 1, right? Okay. So next we'll talk about prime factorization. So prime factorization is breaking down a number into its prime factors, right? So what prime numbers go into a certain number. And so 12 we can write as 2 squared times 3, right? Or we can write it as 2 times 2 times 3, okay? So it's a way to write a number as a product of only prime numbers, okay? And so and obviously 2 times 2 is 2 squared, so that's how we get that. But that's a prime factorization of 12. All right, and we all know that a prime number is a number that has exactly two factors, two different factors, right? So it has exactly two different factors, and it has to be a natural number as well. So if we think about the natural numbers are 1, 2, 3, 4, 5, all the way to infinity, right? So the one common misconception or debate is whether or not 1 is a prime number. So what are the factors of 1? Just 1, right? So that breaks this idea of having two different factors, right? 1 only has one factor, which is itself, right? So so prime numbers have a factor, or have factors, have two distinct factors, 1 and itself, right? Like 2 is actually the smallest prime number. So 2 is a prime number because 2 has exactly two factors, right? 1 and 2. 3 is a prime number. 3 has exactly two factors, 1 and 3. 4 is not a prime number because it has 1, 4, and 2 as a factor. 5 is a prime number, and so forth and so on. Okay, so 2 is the only even prime number, and then all the other prime numbers are odd, but not every odd is a prime number, right? So for example, 9 is not prime because 9 also has 3 as a factor, right? So has more than two factors. So here's a list of all the prime numbers from 1 to 100. So the numbers that are highlighted in blue are all the prime numbers. So just to give you an idea, so we talked about not all odd numbers are prime numbers, right? The first 1, 2, 3 odd numbers are, but then it started at 9. We have some odd numbers that aren't prime numbers, right? Like so 9, 15 is not prime, 21 is not prime, and so forth and so on, right? So the other thing is you can see 2 is the only even prime number, right? So after 2, all the other even numbers are not prime. Okay. All right. So sometimes that's a good list to have. You might want to write those down somewhere in your notes. Just copy down the prime numbers from 1 to 100, 2, 3, 5, 7, etc. because it's a good reference to do what we're about to do next.